So we're going to look at this problem for a second, and then I'm going to zoom in. It says a utility company burns coal to generate electricity. The cost in removing P% of the smokestack pollutants is given by this function. Notice we have a function with a numerator and a denominator with two different functions defined. And then they give us restrictions for letter P. Sketch a graph. You remember the state legislature considering a law that would require utility companies to remove 90%. The current law requires 85%. How much additional cost would the utility company incur? So, let's zoom in on this and take a look and see what we need to figure out. So what we have here, if we're going to sketch a graph, we have this axis of P, which is percent of your pollutants, and then your C, which is cost. So here's our function, and we know at 0 we're going to get 0 in the numerator, so C is going to equal 0. Okay, so C is going to equal 0. So at 0, we're going to get 0. So we get the point 0, 0 here. Now, if it's going to ask to require 95 or 90% removal, we need to figure out just exactly what that is. So let's calculate that. So at 90% removal. So if that's going to be 90, let's see what our cost is going to equal. So we get 80,000 times 90 over 100 minus 90. Which is going to be 72, and then I believe there will be 5 zeros. So 72 or 7.2 million divided by 10. So my cost is going to be 720,000. So up here at 90, it's way up here at 720,000. Okay, so let's take a look at what happens at 85. This is what it's current at. So we have 80,000 times 85 over 100 minus 85, which is 15. Well, 80,000 times 85 is going to be, well, let's get out the calculator and check this real quick. So we have 80,000 times 85. We have 6.8 million. And that's over 15. And what that reduces to, if you divide it, is 453,333. So what's happening with this is it's going to look something like this. The higher you go, or the higher percentage you ask them to remove, it's going to grow at a much steeper rate to ask them to remove it. So the question is, how much more would it cost? Well, we have this amount of money that it would new cost be, and this is the old cost, so you subtract the two, so the new cost difference would be the difference of the two, which is $266,667. Now let's take a look at the last one. For a person with sensitive skin, the amount of time in hours a person can be exposed to the sun with minimal burning is by this function. Find the amounts of time a person with sensitive skin can be exposed when S is 10, 25, and 100. Well, I'm going to show you how it works with one of them, and then you can figure out the other ones. I can write them up there if you want to check them. So for letter A, if S is equal to 10, so this is a Sunser scale reading. So this is the reading of the Sunser scale. So if we're going to find out how much time you can spend in the hours with the time in the sun with minimal burning, we have to plug this in. So I'm going to plug this in for T. And I get that. Now I can't just cancel these out because of this plus. So what I'm left with is 3.7 plus 23.8 over 10. If I add those together, I get 27.5 over 10. Which reduces to 2.75, and that's in hours. Now if you plugged in 25 and 100 into the same thing, you would get two different times in addition. Now if you have a Sunser rating of 25, you get about 1.32 hours. And if you go for 100, if you have that rating, it's 0.61. So this rating allows your number of hours to be dropped. So what this would look like on a graph is that if you had a rating that was going up, it would amount your time in hours to go down, and down fast. Okay? If this function were true for all Sunser ratings, what would be the horizontal asymptote of the function? And what would it represent? Well, if we're going to talk about the horizontal asymptote, the degrees are the same. So if we're going to talk about the horizontal asymptote, the degree in the numerator is equal to the denominator. Okay, so if the degree in the numerator is equal, then we just have to look at leading coefficients. So it is 0.37 over 1. So that's going to be y equals 0.37. So what does that mean? Well, this is a time of burning. Again, this is your time. So this represents the smallest time with minimal burning. So the smallest amount of time you can spend with minimal burning.